Banks don't fail to settle in real time because the rails are slow. They fail because their own books aren't ready. But for the first time, the inside of the bank and the outside rails can actually talk to each other continuously. And when that happens, the entire logic of global settlement changes. From a distance, it still looks like two separate stories. Inside banks, legacy cores, and batch systems make everything feel slow and fragile. Outside banks, Ripple has built an institutional stack that can settle value in seconds. The tension is obvious. If the rails are ready on the outside, why do flows still move like it is 1995 on the inside? In part one of this series, we reframed XRP adoption on the institutional clock, not the retail clock. In part two, we went inside the bank and saw how batch clearing, netting, and intraday liquidity models block real-time settlement. In part three, we shifted outward and walked through Ripple's external stack: Finastra, Treasury, Custody, Prime, RLUSD, and the upgraded XRP ledger built for institutional rules. This chapter is where those worlds finally meet. We are going to follow one continuous loop: how clearing prepares a bank's internal state, how Ripple's rails finalize settlement externally, how Swift and ISO 20022 messaging orchestrate between them, and how Treasury, liquidity, and regulation all feed into that loop. Everything here is for educational and entertainment purposes only, not financial advice. Always do your own research before making any investment decisions. If clear, no hype crypto education helps you make sense of all this. Hit like and subscribe. It tells YouTube this series is worth showing to other newcomers, and it helps me keep building it for you. Up to now, it has been useful to keep the layers separate. It made sense to talk about slow adoption, internal bottlenecks, and external rails as different chapters. But that separation can also create a false picture, as if banks will one day switch from Swift to Ripple, or from old rails to new ones in a single move. In the real system, there is no big switch. There is a layering process. Clearing, settlement, and messaging are already distinct functions. What is changing is how those functions are implemented and which rails they can choose from. Interior upgrades like Yellow do not replace Ripple. They make it possible to use Ripple safely. Ripple's external rails do not replace Swift. They give Swift richer options to orchestrate. So rather than thinking in old versus new, it is more accurate to think in terms of choreography. Clearing decides what should happen. Settlement executes it in the real world. Messaging glues the decisions and the execution together. The architecture Ripple and Yellow are building is about upgrading each part of that choreography without breaking the rest of the dance. Start inside the bank. Before any payment touches an external rail, the bank has to know who owes what, in which currency, and under which constraints. Historically, that happened in batch. Transactions accumulated during the day, netting engines crunched the numbers, and end-of-day processes updated internal ledgers and liquidity positions. Yellow's role is to turn that episodic process into a continuous one. Instead of waiting for a batch window, state channels and programmable netting let banks track exposures in near real time across counterparties and corridors. Intraday. The clearing fabric knows the latest net position between Bank A and Bank B, not yesterday's approximation. Conceptually, that means by the time a payment is ready to move externally, the interior state is already synchronized. Treasury knows which positions are open, which have been offset, and which need final settlement. Compliance logic can be applied continuously instead of at the end of the day. The bank is no longer guessing its way from batch to batch. It is running a live, continuously updated view of its own obligations. Now step outside. Ripple's stack is designed to take those prepared obligations and turn them into real, final settlement across multiple rails. A bank's payment hub can see balances in Ripple's digital dollar, traditional fiat accounts, and, depending on the corridor, access to XRP and other tokenized instruments. Custody and prime brokerage ensure that these assets sit in regulated environments with clear operational controls. When a bank chooses Ripple's rails for a corridor, what it is really choosing is a settlement fabric. The regulated tokenized dollar as digital cash on the rail, tokenized deposits or CBDCs where central banks permit them, and the XRP ledger as a deterministic system capable of finalizing multi-asset movements atomically. From the bank's perspective, it looks like a menu of settlement options. Settle in fiat, settle with the digital dollar, settle through tokenized deposits, all running on the same external infrastructure. The key is that this settlement fabric is always on. Once a corridor is enabled, those rails can finalize value at any time, with clear proofs and reconciled balances returning to the bank's internal systems. But they still depend on the interior clearing fabric to provide the right inputs. A fast rail is only useful when the bank actually knows what it wants to settle. The real magic happens at the handoff point. Inside the bank, Yellow's clearing layer has accumulated a net position and validated it against limits, risk rules, and compliance checks. Outside the bank, Ripple's rails stand ready to move value. The question becomes, how do you move from, "This is what we owe," to, "This has been settled and reconciled," without breaking anything in between? Conceptually, the flow looks like this. First, the clearing layer designates a slice of obligations as ready for settlement. That might be individual payments or a continuously updated net figure. Next, the bank's payment hub packages those obligations into instructions. Which counterparty, which asset, which corridor, which rail. Those instructions are routed toward Ripple's stack, where RLUSD, tokenized money, or XRP-backed paths are chosen based on liquidity, cost, and policy. Once the settlement executes on the XRP ledger or a connected ledger, proofs come back. The bank updates its internal state to reflect the completed movement, and Yellow's clearing layer now sees a new baseline. Exposure reduced, positions updated, liquidity buffers adjusted. Clearing and settlement have just completed a loop, and the system is ready for the next one. Where does SWIFT fit in this picture? In the old world, SWIFT messages were often treated as the payment itself. In reality, they were always instructions, formatted text telling other systems what to do. With ISO 20022 now active, those instructions have become richer, more structured, and better able to describe complex flows. In a multi-rail architecture, that structure matters. A bank can send an ISO 20022 message that does not just say, "Pay this counterparty," but also encodes which corridor, which purpose code, and increasingly, which settlement option is preferred. SWIFT becomes the orchestration layer coordinating between interior clearing, Ripple's external rails, domestic real-time gross settlement systems, and over time, CBDC platforms. In practice, this means SWIFT is not replaced. It is repositioned. The same messaging network that once presided over slow, batch-based correspondent banking can now route instructions toward real-time digital settlement, including flows that land on the XRP ledger via RLUSD or other tokenized instruments. The value moves on Ripple's rails. The choreography still moves through SWIFT-formatted messages that central banks and regulators understand. Once clearing, settlement, and messaging are wired together, Treasury behavior starts to change. In a batch world, treasurers size liquidity for specific windows: end of day, end of cycle, end of month. In a continuous world, they have to think about always-on settlement capacity. That is where Ripple's digital dollar and other regulated tokenized assets become operational tools rather than experiments. If a bank knows that corridor flows can settle at any time, it will hold more immediately usable liquidity in the instruments that settle those flows cleanly. That might mean maintaining positions in the settlement dollar at key hubs, building tokenized deposit buffers, or arranging committed lines that can be drawn into digital form on demand. As those patterns stabilize, Treasury policies harden around them. Minimum balances in Ripple's regulated stablecoin. Maximum exposure by rail. Automated top-ups when levels fall. Every time a settlement loop completes, data feeds back into those policies. Did the corridor consume more or less of the on-ledger dollar than expected? Did XRP bridged routes deliver better execution than direct pairs? Did the timing of flows stress any buffers? Treasurers adjust, risk committees recalibrate, and the next loop runs smoother. Clearing, settlement, and liquidity are now in a live feedback cycle instead of static spreadsheets. None of this turns on everywhere at once. Banks roll it out, corridor by corridor, product by product. They might start with low-risk remittance flows between two well-regulated jurisdictions, using RLUSD as the settlement asset and keeping XRP usage behind the scenes or in tiny increments. As comfort grows, they add corporate payments, then trade flows, then more complex treasury movements. Regulators, for their part, prefer this layered, risk-controlled approach. Interior clearing upgrades like Yellow reduce operational risk by making exposures more visible. External rails like Ripple's Stack run inside licensed entities with custody, prime brokerage, and stablecoin operations under supervision. Swift and ISO 20022 provide a familiar messaging substrate. From a supervisor's perspective, that looks less like a revolution and more like a sequence of controlled migrations. Over time, the result is a mesh of corridors where some flows still run on traditional rails. Some run on Ripple's rails with RLUSD and tokenized deposits, and some eventually make use of XRP as a routing asset when it offers better liquidity or execution. The important point is that each step is justified by operations, risk, and policy, not by speculative narratives. By now, the architecture should feel less mysterious. Clearing no longer lives in a separate universe from settlement. Interior fabrics like Yellow prepare a bank's state continuously. Ripple's external stack turns that state into real, final movements of value. Swift, upgraded by ISO 20022, coordinates instructions across multiple rails. Treasury, liquidity, and regulation close the feedback loop. In that environment, assets like XRP and Ripple's digital dollar stop being abstract ideas and start behaving like components inside a carefully engineered machine. The regulated tokenized dollar acts as digital cash on the rails. XRP sits where fragmented liquidity needs a neutral connector. But the detailed mechanics, how routing engines choose XRP, how the on-ledger dollar and tokenized treasuries shape structural demand, how AMM depth and corridor design reinforce each other, belong to the final chapter. In Part 5, the final chapter, we show how real-time settlement creates structural utility for XRP and Ripple's digital dollar. Thanks for watching, and I'll see you in the next deep dive. This channel is for educational and entertainment purposes only, and is not financial advice. Always do your own research and keep the discussion respectful. If you enjoyed the video, please consider liking, subscribing, leaving a comment, or sharing it with a friend.